So given a quadratic equation, y equals ax squared plus bx plus c. This is the standard form of a quadratic equation. I'm just going to tell you this. X equals negative b over 2a is the equation of the axis of symmetry. Equation of the axis of symmetry. And you're like, what the heck is he talking about? Symmetry, and I'll show you what I'm talking about in a minute. Also, x, or also, yeah, minus b over 2a is the x coordinate, and it's a lot of letters here, of the vertex. Okay. So how does that help me? So it helps me when I'm graphing things. Graph y equals minus 3x squared plus 6x plus 5. Plus 6x plus 5. So in this case, negative b over 2a is equal to, this is b right here. Do you see this? Where that b comes from? It's the middle term in one of these. So b is 6, so negative b would be negative 6, and 2a, what's the number in front of the x squared? That's a.
3.
Negative 3, so what I'd get 2 times negative 3, all right? And when I simplify that, I get negative 6 over negative 6, which is 1, equals 1. All right? So what that tells me is x equals 1. That's the axis of symmetry. Okay? And so that means that, I'll sketch in a minute. And then we're going to find the vertex. The vertex is at 1, because we just found that there. See where it says? It is also negative b over 2a. This number right here is also the x coordinate of the vertex. So given x is 1, how do I figure out what y is? When I plug in 1, I get something out, right? And so y is equal to, when I plug 1 in there, negative 3 times 1 squared plus 6 times 1 plus 5. And when I simplify that, 1 squared is 1 times negative 3 gives you negative 3 plus 6 plus 5 gives you what? What's 6 plus 5 minus 3? Come on. 8. So the vertex is at 1/8. So all of this information here helps you graph this function, right? Because I know the axis of symmetry and I know the vertex, that's the point is at 1/8. So I'm going to try to graph this function. Where am I going to graph it? On graph paper? Sure, let's graph it on graph paper. So capture. Here we go. Place, capture, new page. Oops, it's okay. Okay, except I want to edit. Edit. There must be a better way to do this. Copy. I'm going to put it on graph paper. And I'm going to go edit, paste, and now I have graph paper with my thing, and you say that's taking up way too much room. I'm going to squish it. Okay? Can you kind of see that? Sure. And so now I'm going to try to graph this function. Whoops, I should have lines on both ends. Alright? So what this tells me, okay, is that now I know that the vertex is at 1, 8. So 1 and up 8. 1, 2, 3, 4, 5, 6, 7, 8. Now because there's a negative sign in front, can anyone tell me, is this parabola going upside down or right side up?
Upside down.
Very good, okay, because the negative sign is in front of the x squared. That's kind of what we played with yesterday. It's going to be going upside down. I also know that if I were to draw a line, okay, through this point, okay, this is the axis of symmetry, right, going through that point. So this is the kind of dividing line. That's what divides it in half. So this over here is x equals 1, and this is that point that I just found, 1 gamma 8. And then all you have to do, so I know that this is where it kind of turns, and it's upside down, and then I could graph some other points. Well, to graph some other points, pick a point to the left of 1 and to the right of 1 and plug it into this equation. So when I take a point, so you can take more than one point, so I'm going to plug in, what's a point to the right of 1? What's an easy point to the right of 1? What's to the right of 1? What's 1 to the right of 1? 2, right? So if I plug in 2 in here, I'm going to get out y. So I'm going to plug in 2 in here, and I should have given myself some more room, but I could do that over here. Where's my equation go? Whoops, I lost my equation. Let's go back. How do you go back? Oh, slide. Good. So I'm going to plug in 2 into this equation. So that gives me negative 3 times 2 squared plus 6 times 2. All right, I'm plugging into this equation right here, plus 5. And if I simplify that, I'm going to just do it kind of in my head. 4 times negative 3 gives you negative 12. Plus 12 makes 0. And plus 5 gives you 5. So what that means is I have a point down here, 2, up, 1, 2, 3, 4, 5. There's another point. See? Now I could go one more place to the right. Let's do that. 3, when I plug in 3 in there, I get negative 3 times 3 squared plus 6 times 3 plus 5. And when I do that, I get 9 times 3. Oh, this gets kind of ugly. 9 times 3 is negative 27. 6 times 3 is 18, right? Plus 5, which is negative 27 plus 18 makes negative 9. Plus 5 is I believe, negative 4. So what that tells me is I have another point on this graph, 3, comma, negative 4. So I'm going to come over here, 3, and down 1, 2, 3, 4, and put a point there. Now, since I know this is the axis of symmetry, I can go one place to the left of 1 and find another point, okay? What's one place to the left of 1? What's one place to the left? What's the x value right there? 0. So when I plug in 0, I will also get out 5, because it's got to be symmetric to this point. See that? So over here, I have the point 0, comma 5, because it's symmetric to this point. And when I plug in negative 1, I'm going to get the point that's symmetric to this point. So that's going to be negative 1, negative 4. See that? Because it's got to be even with this point. So I'm going to go back 1, down 4, and there's that point. So now I should be able to sketch in my parabola, which goes like, whoops, no, let me try that again. That's bad. I can erase it. Let me try again. Let's try it in pink. Let me try again. Bad parabola. Not a great parabola, but it doesn't go out that much. That's bad again. Ah!
Having problems?
Yeah. Very. It should be symmetric. It's hard to do with my mobile board, but you get the idea. It doesn't look like it shouldn't be worked like that. This should go more like out like this. Okay. But that is a sketch of that parabola. So I found it by finding the axis of symmetry, and then I found the vertex, and then I took a point to the left and the right of the vertex. Okay? Yeah? And then, just for those of you who are going to leave soon, let me show you one more thing. If instead of this being x, y equals, we have y equals negative 3x squared plus 6x plus 5. If instead of doing that, say I had y is greater than negative 3x squared plus 6x plus 5, because this also involves graphing quadratic inequalities. I'm going to shade somewhere. Where do you guys think I would shade?
Well, I don't know. Tell us.
Above the graph or below the graph?
Good morning, Monarch High
Hold
School.
on. Above the graph or below? Sit down.
Below.
So moving on, if this were a greater than symbol, do you think I would shade above or below this graph? Greater than. Where are all the points where y is bigger than this? Above or below? Hello? Greater than. Above. Okay? It would be above, so you would shade above this graph. Anything that's outside of that parabola would be y is greater than this curve. Okay, so you could just kind of assume that, or if you like, you could plug in this point 0, 0, and y is 0, x is 0. You're going to get out 5 is less than 0, and since that's not true, you shade away from that point 0, 0. But I would just know if this is greater than, you shade outside the parabola, and if this is less than, you shade, or above the parabola, and if this is less than, then you shade below. The other thing with this one, it should actually, if I had it like this, it should actually be a dotted line, right? Because it's not less than or equal to, whoops, I'm messing my graph all up, but it would be a dotted line if it were less than. If it were less than or greater than. If it were greater than or equal to, then be a dotted line. Okay? We're going to try one more. Is that okay? No?
So it's dotted if it's greater than
It's just,
line when it's left.
no, line if it's greater, if it has the bar, if it says greater than or equal to or less, that's one to shade. Okay? So let's try again. This is an easy one. Y equals x squared minus 6x plus 9. So first thing we're going to do is find the axis of symmetry. Really? Okay. Axis of symmetry, x equals negative b over 2a. What's negative b in this case? What's negative b, Lily?
So what's b? Start with where's b?
What's b?
It's ax squared plus.
What's b? Negative 6. So what's negative negative 6? What's a negative negative? Positive. So it's just positive 6. And what's a in this case? A is easy in this case. What's a, Morgan? No, what's in front of the x? What? 1. So what's 2 times 1? 2. Okay? So that makes 6 over 2, and what's that? 3. Okay, so that's 3. So now what I want to do, I also want to find the vertex. Okay? So now that the vertex is going through the point, so this is also the x-coordinate of the vertex. So I know that it goes through 3, comma, something. And the way I find that something is by plugging it into my original equation. So I'm going to go 3 squared, so y equals, in this case, 3 squared minus 6 times 3 plus 9. And so I get 9 minus 18 plus 9. Ooh, that's an easy one. What does that come out to be? What does that come out to be? What's 9 minus 18 plus 9? What's 9 plus 9? What's 18 minus 18? 0. Okay? So I know that the vertex of this parabola goes through the point 3, 0. Alright? It's not that hard. Is this hard? It's kind of easy. Okay? So now what I'm going to do is the same thing I did in the last thing. I'm going to capture this. There must be a better way to do that, but partial. So I'm going to take this info, okay? I'm going to put it on a new piece of graph paper. I'm going to go edit, paste. There it is. That's the wrong thing. Never mind. Edit, undo. I know what I have to do. I have to go back here. I have to copy that. Edit, copy. And I'm going to go back to that piece of graph paper. Edit, paste. Here's all this info. And I'm going to try to graph this function. Okay? So, again, I'm going to make some lines. I'm not going to make them yellow because that's hard to see. I'm not going to make them dotted because that's good for something else. So, here we go. There's one line. There's one axis. There's my y-axis. And I'm going to start plugging in some stuff. So I know that the vertex is at 3, 0. 1, 2, 3, 0. And I also know that the axis of symmetry is x equals 3, right? This is the axis of symmetry, which means that this line, dotted line, that I'm about to draw right here, is the line that cuts that parabola in half. All right? So I know that this is the vertex, and I'm going to pick a point. Is this one going to be going upside down or right side up? Right side up, okay? Because it's got a positive in front of the x squared. And now I'm going to pick a couple points to the left and the right. Okay, so we're going to go x. We're going to give us some room to figure out what y is, and then we're going to go x. Find the points x, comma y. So what's just to the right of 3? 4. Okay, so I'm going to plug in a point there. And when I plug in 4 in here, I get 16 minus 24 plus 9. What's that? Minus 5 plus 9. Did you get out 4? Did I do that right? 16 minus 24 minus 5 plus 9 makes positive 4. So what that tells me is on this graph, I have a point 4, 4. So this is 3, 0. So 4, 4 would be over here and up. Did I do that right? I don't think I did that right. It should just go up 1. Let me see again. 4 is 16 minus
That's 36.
16. Oh, no, I put in 4. 16 minus 24 is, what's 16 minus 24? What's 20? Wait a minute. 8? 8. So it'd be negative 8, so that should be a 1, sorry. That should be a 1, that should be 4, 1. I knew I did something. 4, 1 would be over here. Now because of symmetry, I also have a point, 3 what? What would this point be right here? What's 3, 1, right? Because it's symmetric, right, around the axis. So this is the vertex. Then I think if you find one more point, that'd be enough. So let's find one more point by plugging in. How about if we plug in this point over here, 2? So let's plug in positive 2 and see what I get out. So let's see if I can do it right this time. 2 squared minus 6 times 2. What's 6 times 2? 12 plus 9. So 2 squared is 4, so I get 4 minus 12 plus 9, which gives you 30. What am I doing? 2 squared is 4 minus 12 is negative 8 plus 9 is 1. Oh! I see what I did. I already did that point. That's this point. I'm sorry. I want to get this point by plugging in 1. Okay? So if I plug in 1 in here, I get out, when I plug in 1 in here, I get 1 minus 6 plus 9, which gives you negative 5 plus 9 is 4, I believe. So I have another point, 1, comma 4. So 1, 2, 3, 4. So there's another point, and because of symmetry, I also have a point 5, comma 4. And then you can take your line drawing tool and draw a parabola in orange, okay, through those points. Whoops, kind of squiggled there. And like that, that's better on that side. And you get a parabola that looks something like that. Okay? Yes? So find the axis of symmetry, find the vertex, then plot a couple points. Should I write down those directions, Ms. Lindgren?
I believe
Okay.
that would be a great thing.
Okay, great thing. Okay? For graphing parabolas, here's some better steps. Parabolas. So, 1, find axis of symmetry. Axis of symmetry.
And that's using the negative b over 2.
Yeah. Using x equals negative b over 2a. 2 is find x and find the vertex. That's negative b over 2a, comma, something. And there's some real fancy mathematical lingo, f of negative b over 2a. So what that means is find this x value and take that x value and plug it into the function to see what I get out for the y value. And then 3, plot the vertex and axis, vertex and axis of symmetry. And then 4 is pick points. Pick 2 points on right or left of vertex. And then 5, I would say, sketch the graph. And I would also include in there, use symmetry. know a couple points on the right side, then you could use those 2 points on the right side to find the points on the left side without actually having to plug them into the equation.
However, if you still need to plug them in, it's okay.
If you-
Symmetry's just a little quicker and you'll get there.
Yeah, okay. So, we have these two